Welcome to the third part of the electricity and the magnetism series. In this video, we are going to learn about how to make an electromagnet artificially. Also, what are the uses of an electromagnet and its application. So, without any further delay, let's soar the sky. Videos, we have already learned about what exactly an electromagnet is. In this video, while we are going to know about how do we make an electromagnet artificially, let's quickly glimpse what is an electromagnet is all about. It is nothing but a soft iron core where an insulated wire is wounded. The two ends of the wires are connected to a battery or any source of current. An electromagnet can only work if the current is running through the entire circuit. It cannot work without the current working on it. Then only these particular arrangement will have the magnetic properties and effect around its circumference. So generally electromagnets can be made into two types. Number one, the eye-shaped bar magnet. Number two, the U-shaped horseshoe magnet. Okay, so we will go into the details of these two processes and along with their diagrams. The first process, that is making of a bar or eye-shaped electromagnet. For that, we require a iron core, soft iron, bar-like iron, that is called the iron core, and then we will take insulated copper coil and wound all around it. Okay, this PQ is an iron core where the insulated copper wire is being wounded. Then both the ends of the copper wire are connected to a battery and a key in a series formation, that is side by side. Here you can see B is the cell or the battery that we have used for the current source, and here is a key which would be used to regulate the flow of the current throughout this circuit. Now what happens when the key is closed? The circuit is complete. The current starts flowing from this terminal and passes through the soft iron bar and then comes back here. So the circuit is complete, and while the current is flowing, this particular iron bar, that is PQ, turns into an electromagnet. Now if we open this key, the circuit gets broken. It's incomplete. That means no current is being able to pass through the circuit, and hence the iron bar stops behaving like an electromagnet. So in order to make a normal iron bar behave as an electromagnet, what we need to do is just to connect the cell with an insulated copper wire, wound it all around the iron bar, and a key to regulate the current flow. Once the circuit is complete, the current flows, it will start behaving like an electromagnet. My dear student, this video is extremely important, so please don't skip and watch the entire video for complete understanding. And last but not the least, please don't forget to subscribe Soar the Sky. The second part is how to make a U-shaped or a horseshoe electromagnet. Here we have taken a U-shaped soft iron and named it as PQ. Then in the same way as we have done in case of a soft bar of iron, making it as a bar magnet, here also we will take insulated copper wire and start wounding it from one end of the horseshoe soft iron, and then continue the winding in its other end in such a way that the winding in both the particular hands are in opposite direction. Alright, you can see here we have started the winding so that it's going like this. Once the winding reaches one end of a hand, we have taken it to the other end and started it from the other end of the hand, whereas here it is started from the beginning of the hand. So automatically the winding in this side is exactly opposite to the winding at this side. Why this is done? This is to make sure that both the ends acquire opposite poles. As you can see, this will acquire the south pole and this will acquire the north pole. Then we have connected a battery with one end of the copper insulated wire and the other end is connected to the key, so the circuit is complete. Once again, if we close the key, the current will start flowing from the battery and it will pass through the horseshoe soft iron. And then what will happen? This horseshoe soft iron will start behaving as a horseshoe magnet, that is an electromagnet. But if we open this key, then the circuit will be broken, the current flow will stop and it will also stop behaving like an electromagnet. So this is a very important diagram for this type of horseshoe electromagnet. So please pause the screen and note it down. What are the uses of an electromagnet? Electromagnets are extremely useful to us. Let us see what are its uses. The first one, loading furnaces with iron. In the industries, the iron furnaces which are being made to smelt various metals, those irons are extremely heavy and it's not possible to lift them by hands. There, the electromagnets are used to attract those heavy pieces of iron and then the iron furnaces can be made. The second point, removing iron dust from wounds. In case of any wound, if there is any speck of iron dust present, the external iron dust is present inside the wound, that can be extremely critical and even fatal for the body. So while the surgery or while cleaning up the wounds, the doctors often use small pieces of electromagnets to remove those tiny iron specks, if any, present inside the wounds. The third point, separating magnetic substances from non-magnetic substances. This is very easy. While we have magnetic substances like iron and non-magnetic substances, say for example steel, present nearby electromagnets, we can see that the iron will easily get attracted towards the electromagnet and get separated from the steel. So this way we can separate the magnetic substances from the electromagnetic substances. Number 4, it is also used in lifting heavy pieces of iron scraps from one place to another. In the dump yard, in the place where industrial waste and the city waste is dumped, in those places huge heavy bulk pieces of iron scraps are being loaded. So it's very difficult and inconvenient for human labor to deploy over there, while we can have very easily move them by using the electromagnets. Number 5, electromagnets are also used in electrical gadgets. Many electrical gadgets nowadays uses electromagnets inside them. They are electric bell, the bell outside our house. Electric tram, the tram that we see, the tram. Kolkata is very famous for its trams. We can see in the cities there are trams. Those electric trams use the electromagnets. In any electric motor like fans, the mixer grinders which contain motors inside them, electric motors, those contain electromagnets. Microphones, mics that we use, the loudspeakers, all of them contains electromagnets. So we can very well understand how useful electromagnets are in our day-to-day life. So my dear students, so far if you have liked this video, please go ahead and share it with all your friends so that they also get benefited from all the topics that I have discussed. And please give your feedback in the comments. This is how the inside of an electric bell looks like. You can create an electric belt. You would require some following ingredients. What are those? You require a gong, a metallic gong, a hammer with an armature, adjusting screws, There are insulated copper wires throughout, a horseshoe electromagnet, a battery, a switch, or a bell push. These are the materials. If you acquire those, you can very easily make an electric bell. How does an electric bell works? When normally, initially when the switch is not pushed, the circuit is open. It's not closed, so no current is flowing. The armature is not coming in contact with this horseshoe magnet. The metallic strip is remaining attached to the armature, so no sound is occurring. We are not being able to hear any sound. What happens when we push the bell or like press the switch on? The circuit gets completed over here. It gets completed over here, and then from the battery the current starts to flow, and the horseshoe electromagnet starts acting like a magnet, and it pulls the armature towards itself. The armature being a metal, it is magnetic in nature, it gets attracted towards the electromagnet, and hence the hammer just comes in contact with this gong and the sound is created. Then what happened? Then this metallic strip gets detached from the adjusting screw as it is attached from with the armature. While the armature comes in contact with this magnet, the metallic strip also moves. So this contact breaks from the adjusting screw and the circuit is broken. The current stops flowing. The bell goes back to its initial stage. If we again continuously keep the switch on, we don't move our hand from the switch, then again this thing will get repeated and we will be able to hear the sound in the same way. So this is how, with the help of an electromagnet, an electric bell works. The next topic is Earth's magnetic declination. What is declination? We already know that Earth itself contains some magnetic properties. It has its own magnetic field, due to which if we bring a magnetic compass and point it towards the geographic north of Earth, it always points in north-south direction. That means there is some kind of magnet inside the core of Earth which forces an external magnetic compass to point its needle in the north-south direction. That is the Earth's magnetic south. If we take Earth as a gigantic bar magnet like this, if Earth is consisted of a gigantic bar magnet like this, then its geographic north would be its south pole, and its geographic south would be its north pole. If this is the bar magnet inside the Earth, why? Because that is, we already know that unlike or opposite poles attract each other. We have seen that if we bring a magnetic compass, it always faces itself, it always points north-south direction towards the geographic north of the Earth. That means the opposite of North Pole, that is South Pole, magnetic South Pole, is located inside the Earth, and the magnetic North Pole of Earth is in the geographic South Pole of the Earth. That's why the compass shows its South Pole towards the geographic side. So that is one thing. Now the other thing is, we already know that due to this magnetic field, the compass is showing this, but is it actually showing the exact geographic north as its magnetic north pole? No. You would see some declination in its part. From the exact north, the magnetic north of a magnetic compass shows a bit moved. This particular angle is called the angle of declination of Earth. It is notified, it is represented here by theta angle, and it is taken positive if we put the magnetic compass on the east of the geographic north, and it is taken as negative that if we put the magnetic north of the compass in the west of geographic north.